This video covers section 11.1 on the fundamental counting principle, and I might be able to squeeze 11.2 into the same video. We'll see. So this says if you can choose one item from a group of m items and a second item from a group of n items, then the total number of two item choices is m times n. Sounds kind of confusing, but let's take a look at an example. We have a restaurant that offers 3 appetizers and 2 main courses. How many different ways can a person order a 2-course meal? I like to put blanks, I call them slots, and fill in the slots with the numbers I have. This is my appetizer slot, and this is the main course slot. I can choose any of 3 appetizers. I can choose any of 2 main courses. And what this formula up here tells me to do is just to multiply these together. This tells me I can make 6 different 2-course meals. And what that means is this. Look at a tree. This first part of the tree, these 3 branches are showing me my 3 choices on the appetizers. Let's say my appetizer was salad, some sort of dip, and wings. Then, after I've made that choice, I can choose a main dish. So let's say the 2 main dishes are chicken or beef. Chicken or beef, chicken or beef. And if I read down the branches, this SC, SB, come this way, DC, DB, and the last is WC, WB. That's just reading down the branches, WC, WB. What this stands for is salad followed by chicken, salad followed by beef, dip followed by chicken, dip followed by beef, and then wings followed by chicken, wings followed by beef. And that's how we end up with 6, and that's why we do this multiplication. So if you can understand the scenario here, these are very easy problems to do because all you're doing is multiplying the numbers that you have. This is the semester that you will take your required psychology and social science courses. There are 15 sections of psychology, so that's going to be a blank, and there are 9 sections of social science. So the psychology, there are 15, there are 9 of the social science. All I have to do is multiply that together, which is 135 different choices you could make. You could have the 8 o'clock psychology followed by the 10 o'clock social science, the 8 o'clock psychology followed by the night social science, etc. Now, if there's more than 2 groups of items, pretend you also were going to be taking a math course, we would have another number to multiply by. So if there's more than 2 groups of items, just multiply all of the number of items. So that's what the fundamental counting principle says. The number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. See, our series of successive things was choosing the psychology course, followed by choosing the social science course, or back here, choosing the appetizer, followed by choosing the main dish. That makes a series, but these were individual choices. Individually, psychology, there were 15 choices. Individually, social science, there were 9 choices. So next semester, you are planning on taking 3 courses. So there's our 3 blanks. We have a math course, we have English, and we have humanities. Based on time blocks and highly recommended professors, there are 8 sections of math, 5 sections of English, and 4 of the humanities that you find suitable. Assuming there are no scheduling conflicts, how many different 3-course possibilities are there? So just multiply these together, and we will get 160 different scheduling possibilities. Telephone numbers in the U.S. begin with a 3-digit area code followed by 7-digit local telephone number. 3-digit area code followed by 7 digits for the local. Area codes and local telephone numbers cannot begin with 0 or 1. How many different telephone numbers are possible? All right, I've laid out my blanks. These are the area codes, and this is your 7-digit phone number. So let's just look at area codes for a second. Area code and local telephone numbers cannot begin with 1 or 0s. First off, how many digits are there? What do you think? 9, 10? Well, we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which makes 10 digits. So the area code cannot begin with 0 or 1. So we can't have 0, we can't have 1, which leaves 1, 2, 3, 4, 5, 6, 7, 8 possible numbers in the first slot. Now, can numbers repeat? Like, can you have an area code of 888? Sure. So it's not like we've used one of these and we can't use it again. Because it can be repeated, now we go back up in here. Is it okay to have a 0 or 1 in the second slot? Yes, which means I have 10 numbers that could go in the second slot. How many numbers can go in the third slot? 10 numbers. That's just the area code. Now I have to look at the 7-digit number. The 7-digit number cannot begin with 0 or 1. So I'm in the same situation right here, which I have 8 digits that could go in the first position. How many digits can go anywhere else? Every one of these is going to be 10, because you are allowed to repeat the numbers. You are allowed to use 0 or 1. So this will work out to be 8 times 8 is 64. And then I'm going to group this up this way. 1, 2, 3, 4, 5, 6, 7, 8, 10 to the 8th, which you can type in your calculator if you want to. But anytime you're multiplying by a power of 10, that means add a 0. So I'm looking at 64 followed by 8 zeros. So there's our answer. There are 6,400,000,000 different telephone numbers. All right, a popular brand of pen is available in 13 colors and 5 writing tips. How many different choices of pens do you have with this brand? Well, we only have 2 choices to make. We got to decide what color we want, then we want to decide what the tip should be. Well, how many colors are there? 13. How many writing tips are there? 5. Multiply that together. There are 65 possible choices for your color and your writing tip. A person can order a new car with a choice of 13 possible colors, with or without AC, with or without automatic transmission, with or without power windows, and with or without a CD player. And how many different ways can a new car be ordered with regard to all these options? Well, we got to make out a bunch of slots here. We need a slot for color. We need a slot for AC. We need a slot for the type of transmission. We need one for power windows, and we need one for CD. So clearly there are 13 possible color choices. Now your choices on these others have to do with or without. You have the choice of with or without air conditioning. So either you do or you don't. That's 2 choices on AC. With or without automatic transmission, same deal. Either you have automatic or you don't. Power windows, you either have them or you don't. CD player, you either have it or you don't. So what I'm going to do here is multiply all of this together. 108 different cars that you could choose from. All right, license plates. License plates in a particular state display 4 letters. So that's letter, 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 followed by 2 numbers. Number, number. No special stipulations here. It just says 4 letters followed by 2 numbers. So how many letters in the alphabet are there? 26. It is okay for your letters to repeat. So you could have A, then followed by 2 numbers. Those are those 10 digits we talked about previously. So you have any of 10 numbers that could go here. So this is just a matter of doing this arithmetic now, which equals this, 45697,600, which is 45,697,600 license plates.